Okay, on 48, it is a distance, rate, and time problem. So I like to typically organize those problems in the same manner kind of every single time. So I typically will have a column for the rate, a column for the time, equals the distance, and D equals RT. I used to remember it dirt. D equals RT. So and then I just usually set it up with a distance at the last column. On 48, we have a passenger train, and I believe we have a freight train. And so if you read the first sentence, it tells us that a passenger train can travel 240 miles. Well, that's a distance. In the same amount of time it takes a freight train. So I don't know what the time is, but I'm just going to call it T, and it's the same. And it says that the freight train can go 160 miles. So far, that's really the first sentence. If the average velocity, which is the rate, is 20 miles per hour slower than the average velocity of the passenger train. So it's basically saying the freight train is 20 miles an hour slower. So let's just say that you want to let the passenger train be R. Then the freight train is going to be R minus 20. And of course you can define your variables, T being the time. R is of course the rate or the velocity of the passenger train. I like to do it this way because you can pretty much solve any distance problem if you can organize the data. So then I just set up my equations. So the first equation is R times T equals 240. The second equation, because that's from the passenger, the second equation is from the freight, and that is, I'm going to write this R minus 20, that quantity, times T equals 160. Well, then I am going to go ahead and distribute that T, and so that gives me RT minus 20T equals 160. Well, I really have a system of equations because I have two or more equations. And so notice the RT equals 240. So every time I see an RT, I can just plug in 240 and solve. So I'm going to get negative 20T equals negative 80. I'm going to keep going, and I have T equals 4. Now, that's actually not what the question is, and that's okay, because it wants to know the rate or the velocity of each of those. So we can now go into our chart, and since we know the time is 4, you can now just plug that in. Well, think about this. You can probably do this in your head, that R times 40 equals 240. So that means the rate of the passenger is 60 miles an hour. And then the freight, of course, we can now plug in our R. And so the rate of the freight train is going to be 40 miles per hour. And you can do a quick check, of course, with the rate times time equals the distance.